This glowing, nebulous probability cloud is how standard physics illustrates the atom. But this representation is a mathematical concession, an abstract way to plot probabilities rather than a description of physical reality. Relying on statistical distributions leaves a massive mechanical problem entirely unsolved. It fails to answer the most basic question of structural engineering. How exactly does an atomic system maintain its spatial volume under immense physical forces? The interior of an atom is an intensely violent electrostatic environment. It is packed with negatively charged particles that intensely repel one another. By all logical metrics, this tightly packed system should violently tear itself apart. The fact that matter remains stable suggests an entirely different mechanism at play. Subatomic space is highly unlikely to be governed by random stochastic anomalies. The stability we observe requires strict, rigid mechanical architecture. To keep an atom intact, nature requires a geometric coordinate system. This system must perfectly counterbalance the outward explosive force of repelling electrons with the inward gravitational and electrostatic pull of the nucleus. To truly understand how an atom holds its shape, we have to stop thinking like particle physicists plotting probabilities and start thinking like structural engineers measuring load. In macro-scale engineering, building a structure mostly out of empty space relies on a specific mechanical principle, tensegrity or tensional integrity. In this model of a tensegrity table, you can see how the structure functions by pitting two isolated forces against each other. The solid struts are placed under compression, actively pushing outward. They are restrained by a continuous network of invisible wires, which provide inward tensile force. Because the outward push of the solid struts and the inward pull of the wires perfectly neutralize each other, the table becomes completely self-supporting. The upper platform appears to float, defying gravity through perfectly distributed tension. This specific architectural mechanism allows a structure to maintain a large spatial volume using almost no solid mass. It is the most energy-efficient way to stabilize a system under pressure. If tensegrity allows us to create perfect structural stability out of empty space at the human scale, the mechanics point directly to how nature holds the atomic vacuum open. The search for that exact subatomic architecture consumed the architect and systems theorist Buckminster Fuller. He spent decades working to identify the fundamental geometric coordinate system that nature uses to structure reality. Fuller started his geometric exploration with a very specific, flawless arrangement. This diagram shows 12 identical spheres packed as tightly as mathematically possible around one central sphere. Drawing lines between the center points of these spheres produces this polyhedron, the vector equilibrium. Look at the highlighted radials. It is the only geometric form where every internal vector matches the exact length of every outer edge. In physics, identical vector lengths translate directly to identical force values. Because the inward lengths match the outward lengths perfectly, the vector equilibrium represents a state of absolute omnidirectional balance. When all forces perfectly equalize to zero, there is no fluctuation, no wave, and no movement. This is the universal zero-point field. Existing in absolute equilibrium, this zero point is pure latent potential, the silent geometric scaffolding that precedes physical matter. Before the universe can generate the dynamic, moving parts of an atom, it first requires this perfectly silent, non-fluctuating grid as its foundation. To apply this geometry to matter, the architect Edward Suzuki proposed a model that abandons the electron cloud entirely. He mapped the classical components of the atom directly onto the vector equilibrium framework. In Suzuki's model, the positively charged nucleus sits at the central node, providing continuous tensile force pulling inward. The repelling electrons act as compressional struts, pushing outward against the nuclear pull, forcing the atom's spatial volume to stay open. Electrons do not orbit randomly. They are locked onto rigid geometric tracks defined by the vector equilibrium. The equidistant spacing of these spherical tracks acts as a physical barrier, preventing the violently repulsive electrons from ever colliding. This paints a very different picture of chemistry. Instead of unpredictable chaos, the atom operates on highly ordered, rigid geometric tracking. The entire system achieves stability because the outward push of the electrons and the inward pull of the nucleus eventually lock into perfect vector equilibrium. This geometric framework presents the atom as a physical tensegrity machine, using rigid mathematical tracks to stabilize and balance its immense internal forces. But this creates a new mechanical problem. The vector equilibrium is perfectly static. If the geometry is completely silent, how does the system initiate the movement required to build physical reality? The answer lies in a kinetic torsion Fuller called the jitterbug. This diagram maps the exact sequence where perfect zero-point equilibrium breaks. When stimulated, the matrix twists, folds, and contracts, shifting from silent equilibrium into dynamic disequilibrium. Inside an atom, this torsion is triggered by an asymmetrical load. As components bond or shift, the center of mass moves off-center, placing unequal stress on the atomic geometry. Watch the system respond to that stress. The asymmetrical load physically warps the perfectly circular electron tracks, stretching them into elongated ellipses. This mandatory tensegrity response distributes the shifted weight, preventing the atomic structure from ripping apart. As these warped elliptical tracks fold and revolve around the center, they trace out a specific three-dimensional shape, the torus. This active energy cycle pulls force inward through the top and bottom vortex holes, accelerating it through the center in a continuous loop. The jitterbug motion takes the static, straight lines of the geometric grid and spins them into a dynamic kinetic matrix. The invisible scaffolding of the universe is the static vector equilibrium, but once that geometry begins to spin and fold, the visible active architecture of matter becomes the torus. If this geometric folding dictates the shape of the atom, we have to ask if this toroidal architecture is limited strictly to the subatomic scale, or if it represents a universal physical law. Moving from the microscopic to astrodynamics, observational data shows that stars and planets operate using the exact same donut-shaped nonlinear electromagnetic fields. When a massive star like Betelgeuse absorbs a smaller stellar body, it draws that energy down through the central vortex hole of its toroidal field. As the energy cycles through the center, the star's overall rate of spin increases. Shifting the scale, human biology mirrors this exact dynamic. This diagram highlights the identical geometric structure generated by the human heart, stacked between planetary and galactic models. The heart generates a powerful toroidal field that projects several feet outside the physical body. When biological fields interact, they rely on resonance. As illustrated here, unaligned frequencies create chaotic distortion and fatigue, while resonant frequencies lock in and magnify energy. Mental clarity is the direct result of our personal field achieving geometric alignment with this structure. Across these vastly different systems, from electrons to stellar magnetic fields, the same toroidal mechanics consistently reappear, suggesting a recurring geometric strategy for managing energy and maintaining structural stability. This brings us to the final infinite scale of Buckminster-Fuller's geometric vision. This diagram shows what happens when you take a single vector equilibrium unit and lock it into adjacent identical units, expanding outward in every possible direction. This perfectly tiled, infinitely expanding grid is known as the isotropic vector matrix. Fuller proposed that this matrix functions as a superfluid medium, serving as a unified field that underlies every observable phenomenon. Now, this yields a radical engineering proposition. If we fully map the subatomic tensegrity structure of matter, we are no longer limited to analyzing it. We can manually scale it up. We can envision constructing human-sized buildings, bridges, and deep space aerospace components that perfectly mimic the interlocking geometry of a carbon bond. We could build macro-scale supermaterials using the exact tension and compression ratios that nature uses to build the elements. Underneath the perceived fuzziness and chaos of reality, there are no random anomalies. There is only pristine, mathematically perfect architecture holding the world together in the dark.